And we're back at the Wikipedia atomic orbitals page. So I just want to kind of run through this table again now that we have a little more information. So you see that this is organized by energy level here, right? So energy is getting higher as we go down, which means the electron will be less stable. And here we have our S versions, or our S shapes that can have this high number of nodes and antinodes versus this low number here. It's also showing you how far away from the nucleus you are. So as you get to n equals 7, you're really far from the nucleus. N equals 1 is really close. That's part of why they're actually more stable when they have a low energy level. You can also see that there's the P's here. And these are the 3 different orientations. So these are the 3 P orbitals for n equals 2. And you'll have 3 more for n equals 3. And you'll see that they're the same basic shape. They're dumbbells, but they're changing so that they have more antinodes and nodes, and they're kind of further apart from the nucleus, I guess, as you move out into higher energy levels. Eventually, right, at n equals 3, right, so I guess I should say this, n equals 1, right, the only shape that can have that kind of one node antinode thing is a sphere. Once you get to n equals 2, you've now allowed for this new shape. Dumbbell shapes can also have this node antinode arrangement. When you get to n equals 3, it's like, oh, I can get the sphere, dumbbells, and the weird D guys to have that many nodes. And once you get to 4, well, now you get these Fs. And now, right, now there's a new shape, and that new shape can take on this kind of node and antinode number here. So you just see that as you go higher in energy level, there's more energy sublevels that become available, right? There's only one, excuse me, for n equals 1. There's 2, S and P, for n equals 2. There's 3, S, P, and D, for n equals 3. There's 4, for n equals 4, S, P, D, F, right? And you also see that the number of orbitals per energy sublevel increases as you go from P, or S, which has 1, to P with 3, D has 5, F has 7. And if you remember that each orbital, right, can be occupied by 2 electrons, or 2 electrons can take on that kind of wave shape, the S energy sublevel for n equals 1 can hold a maximum of 2 electrons. 2 electrons can look like this. You get 2 more here, then 2, 4, 6 here. So total, there's 8 electrons that can be in the second energy sublevel. There's 2, 4, 6, 8, 10, 12, 14, 16, 18 for n equals 3. And 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32 electrons that could be in the n equals 4 energy level. So now the thing to think about is electrons will be in the most stable orbit available to them. Right? There's no reason for them to be in, the 7s orbital. There's really no reason for them to be there unless it's the most stable one that they have available. So what happens is when you are thinking about more and more electrons in an atom, you're really thinking about them being filled from the kind of like bottom up, from low energy levels to high. And we'll have a whole nother video on that, but just to know that we're going to get there eventually. So I want you to have a look at this, which is just a nice little demonstration of what we're talking about. So this is for helium, and helium's got 2 electrons. It's got 1 in the 1s, right? So the electron might have a kind of, right, it's kind of probability distribution would look something like this. It's because the wave is that spherical wave. And then there's another electron, and that can also be in the 1s. So the second electron would look like that. If we go to lithium, it's got 1 more. So it's, again, you'll have a 1s. You have a second 1s. Now you've got to go to the next most stable one, which is a 2s, which, remember, has another node, and it's further apart. So there you go. So that's what it looks like. So you can see that there's this area here where there are no electrons, and it's kind of further apart. Carbon, even more. So 1s1, 1s2. Then our 2s1, our 2s2. We've now gone up to 2p, so it has to look like that and like that. That's our last ones. And again, look at those 2p's again, right? Just like those pictures that we saw. And they should hopefully start to make it more solid now.